Hello everyone and welcome again. My name is Mustafa Koç. I am the academician. I am a professor of educational technology at Suleyman Demirel University. My presentation is about a small scale research which is submitted as a requirement of master's degree as a seminar study of my graduate student. The first author is my advisee. This research is about junior high school teachers' self-efficacy levels for STEM practices, a sample of identity. Our research is grounded on two main concepts. The first one is science, technology, engineering, and mathematics education, which stands for STEM education. I guess we are all here quite familiar with this concept, but I would like to remind the characteristics of this approach. And according to the National Research Council, within the STEM approach, science is regarded as both the knowledge and process of inquiry. Technology is the production of devices to meet the needs of human. Engineering is mainly linked to problem-solving processes, and mathematics is a study of pattern and relationships between numbers. Therefore, STEM is a pedagogical approach to synthesize of all these four disciplines, integrating of knowledge and skills of these disciplines. What is the purpose of this approach? Actually, in the literature, there are several types of definition of STEM, but the first two purposes are the commonly said. The first purpose is to develop 21st century skills, especially the 4Cs, which are creativity, critical thinking, communication, and collaboration, and to support problem solving in real world situations, to stimulate interest and engagements towards the STEM fields, and to train qualified individuals needed by the future workforce. And the last purpose is to achieve and sustain economic growth and keep up with the competitiveness in the global market. Let's look at the key characteristics of STEM education. It is less taught by one teacher or department, such as career and technical education or science, but more facilitated by an interdisciplinary team of teachers. STEM is less textbook based, but driven by the book or teacher, but it is more driven by the students or community's interest. It is less problem solving that requires application of basic math or science understanding, but more solving real world problems where students model complex problems, concepts. And it is also less bringing a little science, technology, engineering, and mathematics together into one project, but it's an approach, holistic approach actually, to problem solving that can be applied across all disciplines. Of course, to achieve these goals of STEM education, we need several things that should be cooperate together. Here are some ingredients. The first one is an integrative curriculum, which is one of the cornerstone to achieve the goals actually, because real life problems include more than one discipline in which scientists and engineers need to work in an interdisciplinary fashion. The second ingredient is suitable pedagogical approaches, which are student-centered and problem-based, open-ended, and experiential. The third one is the motivating and engaging context, including STEM labs, clubs, technological tools, competitions, etc. Of course, perhaps the most important ingredient is qualified teachers who is going to bring all together these, and our research is also about the teachers. The second concept of our study is self-efficacy. There are several characteristics of teachers that play an important role in their teaching behaviors and performance. Of these factors, we focused on self-efficacy beliefs in the study. This concept is defined as people's judgments on their own capabilities for specific performance. And in this study, of course, teaching performance. There are some specific characteristics of self-efficient people which result in better performance, and these are able to work harder, longer, have better self-regulation, more actively in control of time, better at task focus, and more interested in their subjects. Self-efficacy for STEM practices. Research showed that although interest and awareness about STEM education are quite high in the schools, there is still a need for more action to improve this area. And the literature review about the factors that have an impact on STEM success highlights the key role of self-efficacy. Therefore, it is important to measure the self-efficacy beliefs of teachers regarding the STEM education. With this in mind, we aim to investigate junior high school high school teachers' self-efficacy levels and its relationships with some demographics. In order to fulfill this purpose, we formed the following questions. What is the level of teachers' self-efficacy for STEM practices? And do their self-efficacy levels for STEM practices differ across gender, work experience, and determining factors for choosing teacher career? We designed this research study as a survey research because our purpose is to explore the current state of junior high school teachers' self-efficacy levels. The first author is a school manager of a junior high school in the city center. Therefore, our population includes teachers working in junior high schools in his city center, using convenience sampling to overcome time and financial limitations, especially in COVID-19 process. Our sample comprised 38 volunteers, and these teachers actually were working in his schools or nearby schools. We use paper and pencil type questionnaire, and this questionnaire has two parts. The first part includes items related to personal demographic information. The second part includes a specific instrument to measure self-efficacy scale. This instrument has a total of 18 Likert type items from 1 never to 5 always. The items is all about STEM competences. Here is the sample item. I am confident in STEM practices. The instrument has one factor, and we calculate the Cronbach alpha internal consistency level as 0.96, which shows that the instrument is quite reliable. Here are the demographic variables of the participants. 70% is male. When we look at their work experience, actually most of them has more than 10 years of working. When we look at the most important reason for choosing the teaching career, we see that personal factors. Almost half of them reported that personal factors have impacted their. And the next one is social surroundings, and the last one is exam score. Here are the descriptive statistics for the scores that participants obtain from the STEM self-efficacy scale. As you see, self-efficacy scores range from 1.44 to 4.28, with a mean score of 2.88, just above the midpoint of its scaling range. And the standard deviation value is 0.72, which shows moderate and narrow dispersions of the data, suggesting that the participants were very close regarding this characteristic. We conduct independent samples tests to explore gender differences, but we couldn't find any differences, as you see. We also conduct an one-way analysis of variance test to find out if there is any differences across the work experiences, but there is no difference. Another one way of ANOVA was conducted to see if there is any difference across the determinant of teaching career, but we couldn't find any differences. Okay, the conclusions is participating teachers on average had a moderate level of self-efficacy for STEM practices. Gender has no effect on their STEM self-efficacy levels, which is really an interesting finding, because we know that gender is an important factor for choosing STEM fields. Especially males select engineering, mathematics more than females, but the self-efficacy level looks like the same here. Work experience has no effect, and determining factor also has no effect on self-efficacy. Based on the findings, we can make some suggestions, including STEM content and applications of teachers, especially in service training programs, can be expanded in a way to increase self-efficacy. They can be encouraged to attend STEM-related activities to get some early experiences, which is very important in self-efficacy, according to Bandra's social cognitive theory. For researching part, future research may explore the effect of other demographic or occupational factors, such as age, branch, school type, either private or public school, or academic career, whether teachers have completed any master degree or doctoral degree, or certificating programs. And experimental or longitudinal studies can be conducted to find out any type of conditions or interventions are influential on self-efficacy. And thank you very much for listening to my presentation.